Hello, welcome to this episode for the ProMine Tip of the Month. In this session, we'll be creating some drift designs for a vein that will be mined by the cut and fill method. It is crucial for an operation to survey the site correctly to then import this information to a software that will model the drifts, calculate tonnage, volume, amount of material, and ore extracted. Having the correct drawings and sections for our drifts enables us to ensure a correct short-term planning and make sure it goes according to our long-term planning. With ProMind, it is easily achievable with our tools inside our 3D drift and our 3D model for our modeling category. In this drawing, we have a vein that has a height of approximately 25 meters and has a width of 2.5 to 3 meters. As we can see, there is already a drift modeled over here, and the extraction will continue in this direction. We will change views to get a better look into our objects inside this drawing. And we can see that we have the drift for the beginning and continues over here to our walls, our back, and our floor points. So to begin drawing our drift, we'll need to configure some of the parameters for our sections as well as the dimension that we want for our drift. The angle in which our vein is resting will also be important for the angles inside our drift so it can follow the ore body correctly. So we'll go over inside 3D drift and open the options menu. And inside drift profile, we'll create a new drift profile called 65 left. And when we edit, we can see more information for our drift. The profile name will be 65 left, which represents the angle at which it's inclined. The height of the drift will be of 3 meters and the width will be of 4 meters. We have the option to either have a symmetric drift, choosing the options from chamfered, arc, or squared, or in this case, a non-symmetric drift, which will adapt to the shape of our ore body. Here we specify the height of the wall survey points. This is the elevation at which the survey was done of 1 meter height. For the left side, the top angle will be of 125 degrees, which would be this angle. And the distance from the bottom would be 1 meter, as well as the height of the wall survey points. The bottom angle would be of 90 degrees, which would be this angle. And our top angle will be also of 125 degrees, as well as our bottom angle. The bottom angle is specified at 125 degrees and not 90. For in this case, we would have a little edge that we would be stumbling upon and would be extracting material that won't be necessary. So we'll leave it at 125. And once we have the section for our drift, we can go ahead and click on OK and close this window. To start drawing our drift, we will turn off the layer for our vein and go to plan view. So once we're in plan view, we can begin to model our drift, and we will start. The date will be left as the actual date. We can choose a layer in where we want to save our drift and the profile selection, which would be the 65 left one that we just created. So to start, we just click on start and it'll ask us to select a wall. And then the other side, and then a back, and a floor point. Now we can continue on clicking on selecting the walls. And we need to select more walls until we get almost to the other side. And during the trajectory, we can select more back and floor points so we can get the most accurate drift for our model. So we click on a back point and on a floor point. We continue drawing in the same direction and picking more points along the way. Here we'll get some more back points, and then we get a wall, another wall, another wall, the last wall, and pick our back and floor points. So once that we've created our drift, we can rotate it to get a better look and see a comparison to our previous drift, as well as get another view of conceptual and compare it to the actual vein. So we can do that by turning on the layer for our vein. And taking a look at the results, we can see that the ore body is being mined correctly. We can also join the meshes that we just created for our drift, and we can join them all with the union command inside our solids module. Now that the drift is joined into one, we can quickly calculate the volume and tonnage for the drift and see that it is 254 cubic meters as well as almost 700 tons. That would be for creating a drift profile. And if you have the polylines for the floor and the back, you can quickly construct a 3D model automatically with the construct 3D model command and selecting the automatic option and select your floor and your back. And quickly, we also have another 3D model for the drift inside the vane and also calculate the tonnage and volume. We can turn on again our vane to get another comparison and see that it was mining inside the ore body correctly. These are just some of the tools that ProMine offers to quickly and easily get 3D models for your mine planning tasks. If you happen to have any questions, please leave them down in the comments section or email us at info@promine.com. Thank you for watching and have a great day.